Hello, my name is Josh Obert, and I am a GIS analyst with the ACPF National Hub. In this video, we're going to discuss the Flow Network Definition Area Threshold Method tool. This is the second tool in the Stream Network and Catchment section of the ACPF Toolbox. Before starting conservation practices using the ACPF, we first needed to define our perennial stream network. Once we have our hydro-conditioned DEM and the associated terrain derivatives, we can start this three-step process of developing our perennial network. First, we delineate a flow network. Second, we'll go in and manually identify which segments are perennial or at least of interest. And then third, we'll define that perennial stream network using the results of step 2. Area threshold is an easily understood method where the user gets to specify a certain threshold, which makes it repeatable, meaning that no matter what watershed we use it in, we can always specify the same threshold if we wish. Briefly, I'd like to discuss what we mean by perennial stream network, and also why we emphasize its importance. A perennial stream network is one which flows continuously. In the first hydrograph, all throughout the water year, there is a base flow. There's a continual flow within that channel. In an intermittent or seasonal stream, flow is only going to occur at certain times of the year when it receives water from, for example, springs or from other surface sources, such as during snowmelt. In the middle hydrograph, for the beginning of the water year, there is no flow. The base flow is at 0. But then, between January and June, there is some flow that's likely due to snowmelt. And then finally, we can have an ephemeral stream, and this is one that only flows in a direct response to precipitation, and whose channel is at all times above the water table, as in the last hydrograph, where there's just sporadic flow occurring, most likely due to an intense rainstorm. For the purpose of the ACPF, we mostly want to be designating our stream network where we are going to be applying conservation practices. For example, one of our last tools is a riparian assessment. So if we are going to be interested in applying riparian buffers or other riparian practices to smaller, potentially intermittent streams, we may want to include those particular streams. For the most part, people are generally only concerned with perennial, that is continuously flowing streams. That is why we make this distinction here. In ArcGIS Pro, we can see our terrain derivatives we obtained from our hydro conditioning process. We have our new DEM, which is now the one that we will use going forward. We will open the catalog window on the right side of the screen if it isn't already open by clicking the catalog tab. Expand our ACPF Pro Toolbox and expand the Develop Stream Network and Catchments drawer. We'll double click on the second tool, Flow Network Definition Area Threshold, to open it. This tool should look very familiar as the inputs are almost identical to our previously run Visualize Flow Paths tool. We've got the same three inputs of flow accumulation, flow direction, and a specified area threshold. We are presented with an optional watershed boundary input. If we include this watershed boundary, the output segments have to be centered within this existing boundary. We should really only do this if we're sure the boundary will not change or will only change slightly. We are not going to include it this time around because we want to see where the flow networks take place based on the landscape. For the first input of flow accumulation, we will choose our flow accumulation layer from the dropdown as it is found in our map. Yours was not in the map, you can navigate to its location after clicking the folder next to the dropdown. After selecting the flow accumulation, the flow direction is populated with the flow direction contained in the same geodatabase that houses our flow accumulation. The one output of the tool, our output flow network, also populates with the flow accumulation selection. This naming convention is also different from the Visualize Flow Paths tool, as it does not include our area threshold in the name. Speaking of area threshold, we also need to fill that in. Compared to the Visualize Flow Paths tool we ran, this time we will enter 15 into the input box for the threshold. We are setting a larger value here, as this flow network will be used to identify our perennial streams, which are more likely to be identified from larger contributing areas. However, this is a subjective choice, and you can do whatever you feel is right for your watershed. If you wanted to delineate more flow that could help identify ephemeral channels, you could choose a value like 5 acres. If you are unsure, you can run this tool a few times and sort out what you would like to identify, and then make your choice from there. Once we have our area threshold set, we'll go down to the bottom of the window and click Run to run this tool. The tool has finished running and our output has been added to our map. By turning the 2-acre visualized flow paths layer from before on and off, we can see that our new area flow network is less extensive. Let's take a closer look at some areas. We can get an idea from our hillshade if this threshold that we chose was significant or not. In our hillshade, we do see some fairly incised channels that the flow network tool did not place features in. If we zoom in closer, we can see these defined channels. If we turn on some imagery, it's hard to tell if they're part of the perennial network or not due to the forest cover. However, because no flow network was placed there by the area threshold network tool, we may want to rerun this tool with a lower threshold, say 10. But if we found this to be significant and extensive enough, this output would work. I generally do choose a lower threshold value just to make sure it does extend far enough into my perennial network. And the reason you want to make sure it does extend beyond the perennial network is due to the second step of the 3-step editing process to code our perennial streams. To give a little preview into that second step of the 3-step process, we'll take a look at the attribute table of our area flow network result. In this attribute table, we have a field called stream type, which right now is populated with all zeros. This will be the field that we are going to edit based on whether a stream segment is perennial or ephemeral or intermittent. This is why it matters if our network extends far enough up beyond the perennial stream, because if it doesn't, then that segment just simply won't exist for us to designate it as a perennial stream. So when we go to develop our stream reach, it won't be complete. To recap, we discussed the flow network delineation and ran the flow network definition area threshold tool to produce our flow network using the area threshold method. The next video in the series will discuss identifying perennial streams to create our stream reach.